Okay, so I think we'll begin. Thank you so much, everyone, for joining us today. My name is Amy Sam. I am the Health Education Project Specialist at the Maxwell and Eleanor Blum Patient and Family Learning Center at Mass General Hospital. Today's program is a special collaboration between the Blum Center and the MGH Preventive Genomics Clinic. Before we begin, just wanted to go over a few items with you all. Please note that this session is being recorded for educational purposes. If you're interested in viewing the recording of today's session, feel free to visit the Blum Center website at massgeneral.org/Blum-Center. Everyone is in listen-only mode. Everyone has been muted so that we can hear our guest speakers today. If you have any questions, please use the chat feature, which is located at the bottom of your screen. We'll have time for them in the end. Only Blum Center staff and our guest speakers will see your questions. Please do not share any personal medical questions or information in the chat box. If you have personal medical question, please ask your doctor. Okay, so if you would like to pull up your slide. So next, I would like to introduce you all to our guest speakers. Today we have Renée Pelletier. She is a genetic counselor at MGH, as well as an affiliate researcher at the Broad Institute. Renée's work focuses on clinical and research initiatives related to genomic medicine and policy, including leading the clinical counseling program in the MGH Preventive Genomics Clinic. In addition to her efforts at MGH and the Broad Institute, she serves on the Public Policy Committee for the National Society of Genetic Counselors. Joining us today, we also have Deanna Brockman. She is a genetic counselor leading research and outreach efforts that span the MGH Center for Genomic Medicine and the Broad Institute's Cardiovascular Disease Initiative. Deanna's work focuses on building an evidence base for understandable and impactful disclosure of genetic risk information, including through polygenic scores. They join us today to give a presentation on direct-to-consumer and consumer-initiated genetic tests. So please join me in welcoming Renée and Deanna.
Hi everyone, as Amy said, I'm Deanna and I'm presenting today with Renée, and we are both genetic counselors at Mass General, and we'll be talking today about at-home genetic testing. So at-home genetic testing can provide you with the opportunity to learn more about your genetic ancestry, to connect with relatives, to explore your physical traits and preferences, and even to better understand your risk to develop diseases. So our learning objectives for today will be to first provide a basic overview of genetics to give you the foundation to understand the differences between genetic testing options. We'll then compare medical genetic testing to at-home genetic testing. We'll talk about what at-home genetic tests can and cannot tell you. We'll discuss some of the resources that are available to learn more and where to find professional support. And then last, we'll talk a little bit about the MGH Preventive Genomics Clinic, where you can discuss your genetic testing options and results that you may have received in the past. I do want to stress again, if you have specific questions about your personal history, we encourage you to make an appointment with us in the PGC. So really the reason that we're here today presenting on this topic is because we know that there is a lot of public interest and enthusiasm for genetic testing that can be done in the comfort of your own home. So you can see from the graph here that the number of at-home genetic tests ordered each year has been increasing significantly, and there are over 25 million people that currently have done an at-home genetic test. And there are many companies offering a variety of tests and services, and it can be challenging at times to figure out which test, if any, is best for you. And because these tests can be bought online or in stores even, oftentimes consumers are not having discussions about these tests with their doctor or other healthcare providers about which test is best for them or what the results mean. And also, I just want to encourage, if there are any healthcare providers who have joined today, hopefully there are some resources here that will help you to empower your patients to make informed decisions about your genetic testing options. And if you'd like some additional assistance, we can provide support in the Preventive Genomics Clinic. So just to start with a bit of background on our genetic code. So our genetic code provides the instructions for our bodies to function. And each of our genetic codes is inherited from our parents, with 50% coming from one parent and 50% coming from the other. And one example that you may be familiar with, shown here in the figure, is blood type. So actually our blood type is a trait that's determined by our genetic code and inherited from our parents. And some people may be surprised to hear that our genetic code is actually pretty similar to other people. So greater than 99.5% is actually identical between people. But it's the small differences in our genetic code that make us unique. It's also important to keep in mind that our genetic code is not always going to determine our health destiny. So for some traits and diseases, both genetics and our environment can influence how they're expressed. So the examples shown here are twins who have identical genetic codes, and we can see that they actually have different outcomes when it comes to weight, depending on their diet. And the last important point that we want to emphasize is that the genetic code can sometimes influence risk to develop disease. So we've shown a picture of an artery in the heart developing a buildup of plaque, leading to a heart attack. And so this is actually a condition that can be triggered by someone's genetic code. So there are medical tests that can provide you with information about your health risks. And these medical genetic tests require a physician or other licensed healthcare provider to order the test. They're typically ordered on the basis of someone's personal medical or family history, and they often can be covered by your insurance if you meet clinical criteria. They can be ordered on a blood sample or saliva or cheek swab even. And importantly, the ordering clinician provides you with care before and after you receive the genetic test results. So for example, if something is found on the genetic test, you'll typically learn that information from your doctor or other healthcare provider who can help to coordinate downstream care. And some examples where a genetic test may actually be ordered for a medical reason is if you or a family member has had a history of cancer at a young age. And so the Blum Center and MGH Cancer Center for Risk Assessment actually had a series of presentations about this topic. So I'd encourage anyone who's interested in this particular topic to tune in for some of those recorded lectures. And then also genetic testing can be ordered in some cases when we're concerned about inherited risk for high cholesterol running in families. So these are just two examples of times when we might order a genetic test for a medical reason. And there actually will be a Blum Center talk on this topic in March. We also might order a medical genetic test if there are particular conditions running in the family. And if there's a genetic change found, we can test other family members for that same variant. And then some of you may be familiar, we can actually order genetic testing when you are either considering a pregnancy or are currently pregnant. And the genetic testing may help you to make pregnancy decisions. And again, we encourage you, if you suspect that there's a genetic disorder running in your family, to discuss this with your healthcare provider. So switching gears to the main topic of today's talk, we'll focus now on at-home genetic tests. So at-home genetic tests may or may not require a doctor to be involved in the process. And it's not always driven by a personal history or family history of disease. So often patients are just curious about their risks and decide to move forward with testing. Often there's no insurance coverage for this testing, and the range can actually be quite wide. So it can be up to a few $1,000s depending on the test. These tests are typically run on saliva or buccal samples, or they can actually be pursued if you have a data file of your genetic code. And we'll talk a little bit more about what that actually means. And again, with these tests, there may or may not be medical support that's included with the results. So sometimes these tests will involve a conversation with a genetic counselor or even a pharmacist, and that just depends on the test that you pursue. And the benefit of at-home genetic testing is that it enables genetic testing to occur outside of a traditional healthcare setting. And there are really three main categories of at-home genetic tests. So the first is direct-to-consumer, the second is consumer-initiated, and the third is third-party interpretation. So direct-to-consumer tests are tests that do not require a doctor to be involved. They're run on saliva or buccal samples typically, and the results should be clinically confirmed before influencing any medical management or clinical decision making. We'll give some examples in just a moment. For consumer-initiated tests, this is a test where the consumer actually orders the test independently, and a doctor must authorize that. Sometimes it's a doctor that is your own doctor, but it can also be a doctor that works for the company, and they have to basically sign off on your request for the test. It also, as I mentioned, may include a genetic counselor or a pharmacist consult, and sometimes these results can even be used as part of clinical care because they meet federal and state laboratory reporting standards. But if you do pursue one of these tests, I would encourage you to talk to your doctor to find out if this is actually one of the tests that does meet these standards. And then the last category is third-party genetic interpretation tools. So these are similar to other at-home genetic tests in that they don't require a doctor to order. However, the main difference is that they actually only require raw genetic data that you've received from one of these other types of at-home genetic tests. And these are tools that can scan for variants across your genetic code and provide a quick interpretation of what those variants may mean for your health and other traits. And these tools are largely under-regulated, and there are several risks associated with this type of tool, which Renée will talk to you about shortly. So just to give you some examples of the different genetic tests that are available and how they actually fall into these different categories if you've already pursued one of these tests or if you're interested in pursuing one of these tests. So we'd like to actually just ask a quick question before we move on to talking more about the tests themselves. So for anyone tuned in, we're wondering if you've done an at-home genetic test.
So we have a poll up, and we'll give it a few more seconds for folks to respond to the question. Okay, so we're going to close the poll.
So it looks like some have pursued an at-home genetic test. So it looks like 35% of participants have, but 65% haven't. So hopefully today, after we talk to you a little bit more about what these tests can tell you, it'll inform some of your decisions if you are interested in pursuing one.
All right, so now we're going to kind of go into some of the considerations, and I think this will be particularly helpful for those who may be thinking about pursuing a test, or if you've done a test in the past and have some questions about how to kind of interpret that information. And so for us, one of the biggest questions that patients have when they come to us with direct-to-consumer or at-home genetic testing results is how accurate are these results? And this ultimately comes down to the technology of the test. So as we mentioned before, there's lots of different genetic tests out there that can be done in the comfort of your home, and the models for those can really vary widely. And similarly, the technology that's used for each test can vary as well. So for most tests out there, we can kind of bucket them into these two groups, genotyping or sequencing. And if we were to kind of compare these two technologies to reading a book, for example, genotyping would kind of be like skimming those pages. You're really only picking up a few words here and there. And when we do this, we can learn some important information for sure, but we might be skipping over some critical information. And this type of testing can be accurate when it does identify a variant in your genetic code, but it definitely doesn't tell us the whole story about your genetics. And in contrast, sequencing is kind of similar to reading every letter on the page. In this case, our reading is a lot more thorough. We can identify important pieces of information and know at the same time that there's a much less likelihood that we're missing any information as opposed to when we just skim that page. So For example, if we were to kind of use one genetic test that's out there on the market, 23andMe is able to report on BRCA 1 and 2 variants. And this gained a lot of press a few years ago when this was approved by the FDA. But in the genetics community, we really wanted people to understand what this really meant. And that's because 23andMe uses a genotyping method for their genetic testing, not sequencing. And actually, they're only looking at 3 common variants, and those common variants are most applicable to people with Ashkenazi Jewish ancestry. So if a person is looking to get BRCA testing through this test and they don't have Jewish ancestry, it's probably not the best test for them. And it's possible that if they get a negative result, it's not because they don't have a variant in one of those genes. It's really just that this technology was not meant to pick up one of the rare variants that they might have. So we really want to be careful when we're thinking about that technology. What's the chance of those false negative results? And especially this is important for conditions where rare variants might be a consideration for the patient. If the technology being used is something like sequencing, which is most of the technology that we use for BRCA testing in the clinic, that can help us know that there's a lower chance for false negatives and actually a higher likelihood that we can pick up any of those rare variants that might be important for someone's care. Now, a couple years ago in 2018, there was a lot of press around the accuracy and false positive rates of these direct-to-consumer tests. And so, as we mentioned before, it's really advised to get clinical confirmation of results that are reported by these direct-to-consumer tests before using this information for your clinical care. And this is mostly out of concern for these false positive results. So that genotyping method isn't always as good, as we said, at identifying or correctly identifying those rare variants. And in one study in 2018, it was reported that up to 40% of positive results were false positives. But I think some of the media was a little bit misleading in this case because a lot of the results that were false positives were actually the result of those third-party interpretations that Deanna had just mentioned. So it wasn't necessarily coming directly from these companies that were reporting this information. So it wasn't an inaccurate report directly from 23andMe, for example, but it was actually the result of someone taking that raw data and uploading it to a site that was providing additional information. And really what we're running into in those cases is these third-party interpretation sites are not as regulated as the other tests that might be, doing some other internal confirmation of those variants before they're putting it on a report. So it really is important to just think about this. And if you do get a positive result, we want to be sure that anyone is bringing that to their physician before they do anything with that information to understand if clinical confirmation at a different lab would be something that would be warranted. So I think one of the big reasons that people have engaged in at-home genetic testing was really a result of the massive amount of information that was coming out about the ability of these tests to reveal where one's biological ancestors may have lived. And I think this is a really fun tool for a lot of people to learn about the history of their own DNA. Some cases it can be really helpful to find relatives out there and really build out your family tree. And this technology works by analyzing various sites in a person's genetic code and comparing it to a reference database of people around the world. And when we see certain commonalities in genetic information between people, we can then use that information to make an informed estimate of what geographical reference populations in the world that person might be similar to. So on the right, you'll see that at DNA site 1, there are 4 different versions of this site. So people might have one of these 4 versions of this specific DNA spot. And we call each of these variants. And these variants don't necessarily always affect our biology, but they do make us unique. And then for this patient, for her DNA site 1, we can say she had the dark green version for simplicity's sake. To find out what ancestry this might relate to, we look at those databases of DNA from people around the world. And when we compare across people from different areas, we start to see trends of how often certain variants are seen in different groups. So for example, in this case, the dark green version of DNA site 1 is the most represented in people of Asian ancestry. However, in the European population, it's actually the least common among the 4 variants of that site. So based on this information, it's more likely that this particular person has Asian ancestors. But this is one DNA site, and as you can see, we still see it represented in people with European and African ancestry. So how do we know for sure? This is where we look at lots of different DNA sites. So we need to repeat this process across many, hundreds to millions of sites across the genetic code to give a clearer estimate of this person's ancestry. So once the results come in, they can take all of that data and kind of give us an average. So for this person, when they repeated that across many different genetic sites, they were able to determine that it's most likely that this person is of Asian ancestry, but also has some European ancestry in there. I think what's important to recognize, though, is this might change over time and can vary on the company that's being used. So each company might be using or have access to different reference databases, and each company is updating their own reference database over time as more people are tested. So, changes of these frequencies and these numbers actually might occur over time. If you've done one of these ancestry tests, you might get an update and say, oh, you were at 50% before, you're down to 25%. And this is an evolving field, so it might change over time multiple times. An additional aspect is, as we mentioned before, if someone's doing a testing like this where we have a lot of information about their genetic information, and we can use that to compare people in those databases to identify if there are other relatives, that have tested at that company. One other thing that we wanted to mention is, what's the accuracy of this? And of course, that can change over time, but it also varies among different geographical groups. So some people might not be accurately represented or underrepresented in these databases. And this is often due to, unfortunately, historical exclusion of populations in these genetic databases. We can really attribute this to racism. So explicit exclusion of specific groups or implicit biases and recruiting strategies for building out these databases. And then in addition to that, some populations might be contributing less to these databases, maybe due to differences in cultural values or distrust in the medical community. Again, often can be traced back to historical racism and eugenics movements. And genetic ancestry, even though some of the marketing campaigns might want to make us think this, but it's not a proxy for identity, culture, or race. All of these things are social constructs, and they can't really be measured by a genetic test. So just because a test tells you a specific percentage, that doesn't necessarily mean you need to identify a certain way. It doesn't change your identity. It just gives you a little bit more historical information about your DNA. Oops. So the next kind of piece of information you can learn from this type of testing is health information. So this can identify genetic variants that are known or suspected to be associated with particular diseases, health risks, or traits. And some examples of things that you can learn from this would be things like carrier status. So the chance that you carry a genetic change that doesn't necessarily affect your own health, but could have the chance to mean that you could have a child with a particular genetic disorder if your reproductive partner is also a carrier. Another category of information you could get related to health would be risk for specific diseases. So this can vary a lot in terms of the severity of the disease that they're reporting, the likelihood of actually developing that disease if you have a risk variant. Every test is different in terms of what health information they provide. So you're going to want to look at at the diseases that they're testing for and really see if that's pieces of information that you would actually want to know, if that's something that could be actionable, and maybe if there might be another test out there that's a little bit more accurate for that, that type of disease risk. And then finally, some of these tests allow you to learn some personal traits like, do you like cilantro? What color are your eyes likely to be? These can be fun to learn, but they're often the most tricky to actually accurately predict with genetics. A lot of these things are a combination of our genes and our environment. So it's a little bit hard for us to accurately say that our genetic information is the sole contributor to those personal traits, because we know our environment is such a powerful influence on those things. Along these lines, I think it's important to beware of some tests that overpromise. So you can see on the left here, this is an actual genetic test that was marketed called the superhero DNA test. They were kind of looking at things related to intelligence and super strength and things like that. Things that we know have a very, very strong environmental component in addition to our genetics. So a lot of these tests are being marketed to identify these health issues and traits. So it's important to really be thinking about, is this something that could be predicted solely by genetics? And, if you are still moving forward with that test, knowing that this is just a small piece of the puzzle for that specific trait. You're only learning a small piece of that picture. In addition, a lot of these tests are based on very limited information or data about the association between their genetics and that specific trait at hand. So this can make some things unreliable for making predictions about what may or may not happen in the future, or what treatment options or management options you might have for that information. And often, if a company is not really trustworthy in giving you good information and relying on sound science, it might not be trustworthy in other ways. So on the right here, you can actually see this specific company did have some scandal a couple years ago in terms of potentially tampering with results and giving inaccurate results. So just always something that we want to keep in mind. And because of this, we wanted to bring up some of the key words or regulatory bodies that you might want to look out for if you're pursuing a genetic test like this. So some important regulatory bodies that you might want to keep in mind would be CLIA. So this is Clinical Laboratory Improvement Amendments, and CAP, the College of American Pathologists. So these really are bodies that regulate genetic tests to make sure that they're accurate, reliable, and timely. So this is really looking at the process from start to finish of a genetic test to make sure it's being done in a sound way. And then for any test that's involving a diagnosis or guiding medical treatment, this needs to be regulated by the US Food and Drug Administration, the FDA. So that's another label that you might see on some of the tests that you're looking at. If they don't have these things, that might be a red flag that this might not be an accurate or reliable test. But of course, even if a test is approved by these regulatory bodies, genetics is very nuanced. So I think if you're really curious about if this is the right test for you, or if it's an accurate test, you might want to find a healthcare provider who specializes in genetics, like a genetic counselor or geneticist, who can help you learn if it's the right test. A lot of people in more recent years have become increasingly concerned about privacy considerations for genetic testing. And we wanted to highlight that one of the attractive parts of direct-to-consumer at-home genetic tests is that it's not necessarily tied, if your clinician isn't ordering it, it's not tied to your medical record unless you're sharing it directly with your medical providers. And there actually is a piece of federal legislation that can protect people against your genetic information being used inappropriately. So this Genetic Information Non-Discrimination Act, also called GINA, was passed in 2008, and it actually prevents health insurers and employers from using your genetic information in decision-making about insurance eligibility, your coverage decisions, or even your employment decisions. One limitation of this law is that it doesn't apply to disability, long-term care, or life insurance. So there aren't those federal protections in place. Doesn't mean that these entities are always discriminating, but we just don't have that protection. So there is that layer of risk that we can't account for. And it's really important to think about, what are the protections that that specific company is using to protect your genetic data? Um, as we mentioned before, these are outside entities. They're not necessarily regulated by the same bodies that regulate your medical record. So what are the privacy policies in place that this company has? And every company really should have a privacy statement on their website to outline how your genetic information is used. So some of those things might include, are samples being stored, shared, sold, or destroyed after analysis? Who owns your genetic data? What protections are in place to avoid some sort of security breach? Can you withdraw your sample from company databases? If your data is shared, is it done in a de-identified way that couldn't be tracked back to your personal information? And are there ways to actually opt out of data sharing practices or research so you can still gain information, but maybe keep your data a little bit more protected? Again, every company is going to have different policies in place, so we can't say for sure what each company should be doing or is doing, but it's good to just really double check these policies before pursuing a test. A lot of this, we just wanted to mention briefly, came to light in terms of how these privacy policies intersect with law enforcement, actually. This came to life with the infamous Golden State Killer case, who in 2008, this man was identified when law enforcement ran an unidentified suspect DNA through a genetic genealogy match site. And when they found a match with a distant cousin, this really greatly narrowed their search and was able to identify the killer in the case. And in the US, this isn't really a new concept, right? Law enforcement agencies, we know, are using DNA to help solve cases. And there are databases that are regulated by our government for DNA. But this case was unique because there are some services out there, like this particular one, GED Match, that allow consumers to upload their raw genetic data, as we said before, for the sole purpose of finding familial connections. In this case, they actually used this GED Match service to identify familial connections for this suspect, and that raised a lot of questions of, is this something that we should be doing regularly? How should we be informing consumers of this risk? If you're uploading information to find familial connections, is it fair for it to also be used for solving a case that you didn't necessarily consent to help with? So the legal and regulatory landscape of how law enforcement can actually use this information is rapidly changing. I don't think it's probably fair to, give specifics on that because it's changing probably daily, and it varies greatly by state. So just another thing to keep in mind if you're uploading your data to any additional databases beyond that company, just to think a little bit deeply about how that information could be used in unanticipated ways. And finally, it's really important, I think, for consumers to think about what information they could get back and what information that they could get back that they're not necessarily expecting. And sometimes this can have an emotional toll on consumers in a way that they weren't necessarily prepared for. So there have been a lot of articles that have come out and a lot of stories that have come out from people who have used these tests to, learn their ancestry and then identified some family secrets that have been, kind of brushed under the rug for many years. These can be really traumatic for families to learn. Sometimes it can be really powerful and a really great thing. But I think it's always important to reflect upon your own family dynamics and even have, before you do a test like this, maybe even talk to your family members. If I do this, this might affect all of you. Is that something that we're all comfortable with? In addition to that, those family dynamics, you can learn, some risk information about your own health that might be triggering to learn or a little bit difficult to cope with, such as learning about Alzheimer's disease risk, which doesn't necessarily have any treatment to mitigate those risks. And then finally, up at the top, you'll see an article title. And I think this goes back to the discussion earlier about the diversity of these reference genomes. And, for some Black Americans, genetic testing can really open up some past wounds. They can be related to, study exclusion for study participation, eugenics movements, and even tracing back ancestry to before the transatlantic slave trade. And that can be, a lot of information for someone to take on at one time. So I think it's just important to think about these things before engaging. So just to kind of wrap up on this piece, if you're considering an at-home genetic test, or if you have done one and are trying to put that in context a little bit more, I think these are some questions that we wanted to just leave you all with. So what information am I trying to learn? Am I trying to learn about health? And if so, is this the right test for that? What technology is this company using for this testing? Are they using genotyping or sequencing? Is that the right technology for the information that I'm trying to learn? And that can, I think, be a lot for a consumer to kind of navigate on their own. So the next question really is, what type of support is really being offered by this company if you have questions about those results? Is there genetic counseling built into the company? I think a lot of the tests that are at home and consumer mediated but involve a physician are a little bit better in terms of providing that support, but it still does vary. So it's important to look into that a little bit. Like we said before, what types of regulatory bodies have taken a look at this test and approved it? What ones haven't and why? That's an important question to be asking. What privacy protections does this company provide for my genetic data? And then am I willing, am I in a place that I'm willing to learn unexpected information about health risks, ancestry, or even those family relationships? So in light of all of these questions and kind of the influx of genetic testing that's being offered, at MGH, we actually started a clinic that can assist patients who might have questions about their results. So we are called the Preventive Genomics Clinic. Deanna and myself are two of the genetic counselors involved in seeing patients, and we also see patients with two providers and have an additional team of fantastic genetic counseling assistants and clinical geneticists who help us really comprehensively take care of patients who have questions about their genetics. So one of the first categories of patients that we see are folks who are looking to have guidance on, who might be asymptomatic and are looking for guidance about their existing genetic testing results. So this might be someone who had a 23andMe test and they want to know what types of follow-up would be necessary should clinical confirmation be a next step. So we can kind of help guide through that process. There are also folks who come into our clinic who want to discuss genetic testing for either their own symptoms or family history. If someone has specific symptoms, we often will refer out to one of the specialty genetics groups at Mass General that also exist. But particularly if people have just questions about, is this family history even something that could be genetics, we can be one of the first places to go to kind of help guide where they should end up next. And then finally, there are people who are curious about their genetics and maybe don't feel comfortable doing an at-home test, but want to do it in the comfort of or the context of a clinical team that can kind of guide them through the pre-test and post-test considerations. So we absolutely can help folks really explore what options are available to them clinically, discuss all of the pricing that might be involved. A lot of this proactive testing is not covered by insurance, so we go through all of the available opportunities there, and really just guide people who are curious or concerned. And you can see our website down at the bottom right there. And just for some additional resources, I know there might be some people on this Zoom call that are not in the Boston area who might not be able to travel for a preventive genomics clinic appointment, even though we are seeing people virtually. We did want to provide some additional resources. So if anyone's looking to find a genetic counselor specifically in their area, NSGC, the National Society of Genetic Counselors, is a great resource. And for unexpected results about family relationships, there's actually a specific genetic counselor who specializes in this. Her company is called Watershed DNA. And she has a lot of blogs and support groups for people who have learned unexpected family relationships through at-home testing. All right, and we just wanted to say thank you to everyone who has joined, and I guess we can open it up to questions. This is the information for our Preventive Genomics Clinic, and then an individual contact information for Deanna and myself.
Thank you so much, Renee and Deanna. So now we're at the end of the session. If you have any questions for the guest speakers, feel free to enter them in the chat box located at the bottom of your screen.
A quick question came in about the Preventive Genomics Clinic, if a referral is required. So that is one of those things that we don't necessarily know until you reach out to us. So it usually is insurance dependent. So if you reach out to us and place a self-referral, we can then reach out to your providers if a referral is indicated based on your insurance. And usually that's something that you can just check with your insurance before scheduling a specialty appointment. But our genetic counseling assistant is lovely, and she will check that before anyone's scheduled to make sure that we're seeing you appropriately. Did you want to take this one, Deanna?
There's a question about online resources available that compare the different types of consumer at-home genetic tests. To my knowledge, that doesn't exist, but we can look into that further. And if there is something, we did recently set up a website for genetics and genomics at Mass General, and we'll be posting more information and resources that are available. So if there's anything that we learn that's helpful like this, we'll be posting it there.
Another question came in about what a visit would be like in our clinic. Of course, right now, first and foremost, it would most likely be virtual. So we are doing most appointments by Zoom using the features that are available through MGH. So people would log in through their patient gateway and meet with us virtually via Zoom. We do also have the ability to see people in person if that's of interest to patients. Depending on the reason for consultation, a person might have their initial visit with a genetic counselor only, or with a joint visit with a genetic counselor and a physician. Usually at that time, we go through some of the risks and benefits or specifics of a person's family history, risks and benefits of testing. And then if testing is indicated, talk about the insurance piece and coverage. And then once that information is kind of collected, we can kind of make a joint decision together if genetic testing is the right course for that patient. And then if that's done, usually we'll have the patient come back for a follow-up appointment to review those results in 4 to 6 weeks, depending on the length of time it takes for that test to come back.
So we'll probably give it about another minute or two to see if anyone else have any questions in the meantime. Renee, Deanna, do you have any final thoughts you'd like to share with the audience?
Yeah, I mean, I think thank you to the Blum Center for allowing us to speak on this topic. I think it's a topic that we frequently are answering questions about in our clinic. So we're just really glad that we were able to reach additional people, and hopefully people learned some helpful information today. I don't think I see any other questions coming in.
I don't think I see any other questions, so I think we could probably wrap up early. As you can see on your screen, they have shared contact information, email, website, phone number, if you want to get in touch with them. And if you want to view the recording of today's session, again, feel free to visit the Blum Center website. It's massgeneral.org/Blum-Center, and I'll type that in the chat box as well. So I think we'll end a few minutes early. Thank you so much, Deanna and Renee, for this very helpful session. I hope everyone enjoyed today's session, and thank you for joining us today. Have a good rest of the day.
Thank you.
Thank you.